Welcome friends, this is Atanu Chaudhary of SureSolve. Continuing from the first part, in the second part of the video, we'll solve the last 5 questions of SSC CGL Solution Set 58 on Algebra 14 from suresolve.com. Let's start solving the first problem. Question 6 is, if x equal to root 5 plus root 3 and y equal to root 5 minus root 3, then the value of x to the power 4 minus y to the power 4 is option A 16, option B 544, option C 64 root 15 and option D 32 root 15. X to the power 4 minus y to the power 4 has two factors. X to the power 4 minus y to the power 4 equal to x square plus y square multiplied by x square minus y square. Taking up the first factor, the third middle term 2 root 15 cancel out in x square plus y square and the result is numeric 16. X square plus y square equal to 2 times 8 equal to 16. On the other hand, for the other factor x square minus y square, the square of the third terms are cancelled out with the result x square minus y square equal to 4 root 15. So, x to the power 4 minus y to the power 4 equal to x square plus y square multiplied by x square minus y square equal to 16 times 4 root 15 equal to 64 root 15. This is the quickest solution done in mind. Answer is option C 64 root 15. Let's solve the next problem. Question 7 is, let p equal to 5 by 18, then 27 p cube minus 1 by 216 minus 9 by 2 p square plus 1 by 4 p is equal to option A 4 by 27, option B 10 by 27, option C 5 by 27 and option D 8 by 27. The challenge in this problem is to find the easiest path to the solution that involves least amount of calculation. The only way to do this is to transform the given expression to a sum of cubes if possible. Let's try. The given expression 27p cube minus 1 by 216 minus 9 by 2 times p square plus 1 by 4p equal to 3p whole cube minus 3 times 3p whole square times 1 by 6 plus 3 times 3p times 1 by 6 whole square minus 1 by 6 whole cube. Equal to 3p minus 1 by 6 whole cube equal to 5 by 6 minus 1 by 6 whole cube equal to 8 by 27. Answer is option D 8 by 27. Matching the terms of the given expression with the expansion of 3p minus 1 by 6 whole cube is easy, and once the terms get matched, the calculations are simple and quick. Let's solve the next problem. Question 8 is, for real x plus y plus z equal to 6, the value of x minus 1 whole cube plus y minus 2 whole cube plus z minus 3 whole cube is option A 3xyz, option B 3 times x minus 1 times y minus 2 times z minus 3, option C 2 times x minus 1 times y minus 2 times z minus 3 and option D x minus 1 times y minus 2 times z minus 3. If you add the three terms x minus 1, y minus 2 and z minus 3 from the direct sum of cubes, you get x minus 1 plus y minus 2 plus z minus 3 equal to x plus y plus z minus 6 equal to 0 from the given expression. This is the key pattern discovery. With the sum of the expressions as 0, sum of their cubes will be 3 times their product. That is 3 times x minus 1 times y minus 2 times z minus 3. This is application of 3 variable zero sum principle, where the compound variables in this case are, say, p equal to x minus 1, q equal to y minus 2 and r equal to z minus 3. So we have p plus q plus r equal to 0 or p plus q equal to minus r. Or p plus q whole cube equal to minus r cube. Or p cube plus q cube plus r cube plus 3pq multiplied by p plus q equal to 0. Or p cube plus q cube plus r cube equal to 3pqr. This is a standard result for zero sum of three variables, simple or compound. If you can identify the pattern, the problem is solved in no time. Answer is option B, 3 times x minus 1 times y minus 2 times z minus 3. Next problem now. Question 9 is, if x plus 1 by x equal to root 3, then the value of x to the power 30 plus x to the power 24 plus x to the power 18 plus x to the power 12 plus x to the power 6 plus 1 is option A 1, option B root 3, option C minus root 3 and option D 0. The consistent pattern in the powers of x is each power is a multiple of 3. That means the key to solving the problem lies in cube of x. Again, we find the given expression a sum of inverses in x. So we explore the evaluation of sum of inverse of cubes of x, that is x cube plus minus 1 by x cube from the given expression. Given is x plus 1 by x equal to root 3. Square up and rearrange the terms, you will get x square minus 1 plus 1 by x square equal to 0. We recognize the expression as the second factor in x cube plus 1 by x cube, and so x cube plus 1 by x cube equal to x plus 1 by x multiplied by x square minus 1 plus 1 by x square equal to 0. Now we discovered that each pair of terms of the target expression with difference of power in x as 6 can be converted to a sum of inverses of cubes of x. The target expression has 3 such pairs of terms, and so the result will be 0. Let's show you. The target expression is E equal to x to the power 30 plus x to the power 24 plus x to the power 18 plus x to the power 12 plus x to the power 6 plus 1 equal to x to the power 27 times x cube plus 1 by x cube plus x to the power 15 times x cube plus 1 by x cube plus x cube times x cube plus 1 by x cube equal to 0. Answer is option D 0. Can be easily solved in mind. Let's solve the last problem. Question 10 is, if p by a plus q by b plus r by c equal to 1 and a by p plus b by q plus c by r equal to 0, where a, b, c and p, q, r are non-zero, the value of p square by a square plus q square by b square plus r square by c square is option A 1, option B minus 1, option C 2 and option D 0. The problem looks complex with no less than 6 variables, but it is easy to see that p by a, q by b and r by c appear in the whole problem essentially in the same form. The 2 variables in each of these 3 are always in mutually divided form. It is as if each of these 3 is acting as 3 independent variables. Assuming dummy variables x, y and z for these 3 does not change the problem at all, rather simplifies it greatly. So we imagine x equal to p by a, y equal to q by b and z equal to r by c. And the given problem is simplified to, if x plus y plus z equal to 1 and 1 by x plus 1 by y plus 1 by z equal to 0, find the value of x square plus y square plus z square. This is a case of solving a simpler problem. We don't need the original 6 variables anymore. From the second equation, Adding up the three terms, we get xy plus yz plus zx divided by xyz equal to 0. Or xy plus yz plus zx equal to 0. So, x square plus y square plus z square equal to x plus y plus z whole square minus 2 times xy plus yz plus zx equal to 1. Answer is option A1. With awareness of how to simplify a complex looking problem by dummy variable substitution, this problem is solved just in a few steps, all in mind. To read the detailed solutions, refer to the article in our website suresolve.com. The link is in the description of this video. And for latest updates, subscribe to our channel. Thanks for watching.